Hello everyone, my name is Wizo NTR. Today I'm going to show you how to calculate reactions on a simply supported beam. So let's start. So if you can check on the screen, I'm having 10 kilonewton, 20 kilonewton and 10 kilonewton with the distance. If you can check, we have 1 meter, 1 meter, 2 meters, then and 1 meter. So RL and RR. So let's start to identify the clockwise forces and anti-clockwise forces. If you can check, I'm having 20 kilonewton, 10 kilonewton, which are on the right of RR, and then force which is on the left of RR. So when we calculate, we take moments around one of the reactions. Now let me take moment around RL to find RR. So I will say anti-clockwise moments equals to clockwise moments. This is the formula we use when we calculate reactions. So we go to the beam. So on the beam, it's where we will identify those anti-clockwise forces and clockwise forces. Okay, let's check on the beam. We are taking moments around RL to find RR. So it means 10 kilonewton and 20 kilonewton and 10, they are on the left hand side. It means they are anti-clockwise. So and RR is on the left and opposing these forces, which means it's going to be a clockwise force. So let's see, I'm moving 10 kilonewton. This one, I will write it as anti-clockwise force. This is an anti-clockwise force. Let me do it in this way, anti-clockwise force, and this one, it will be anti. Another one also, let me change here. So yeah, to be like this. Okay, this one, it will be anti-clockwise. So then RR is going to be clockwise. This one is clockwise force. RR is going to be clockwise. Let me put it like this. This one is clockwise. This is clockwise force. So yeah, like this. Let me delete here. Okay, let me do something like this. Okay, this one is our clockwise force, and that one is the anti-clockwise force. So let's go and calculate our reactions. So let's start with the anti-clockwise forces or anti-clockwise moments. Okay, so let me change the spelling here, or to be anti. Yeah, okay, it seems like everything is fine with me here. So let me start. It's 10 kilonewton, multiplied by the distance of 1 meter, then plus 20 kilonewton multiplied by the distance. Our distance is 1 meter. Let me check. We are taking moment around RL to find RR. Take moment around RL to find RR. This one, it will be plus 3 meters, 10 kilonewton, multiply by the distance. Our distance, or it will be RR multiplied by 4 meters. So 10 kilonewton multiplied by 1 plus it will be 10 kilonewton, and then 20 kilonewton multiplied by 3, it will be 60 kilonewton, then plus 50 kilonewton per meter. Or this one, sorry, not 50 kilonewton per meter, 50 kilonewton meter equals to 4 rm. So equals to, then we will add this one, 10 plus 60 plus 50 kilonewton meter equals to, or let's go to the calculator so that we can see what to do. Is 10 plus 60 plus 50. Okay, let me do it like this. It's 10 plus 10 plus 60 plus 50. It's 120. 120 divided by 4. It will be our RR. So that's what I'm doing here. You have to divide it by 4 so that you can get your RR. So let me go to the calculator again. Then I will divide by 4 equals to. So 30 kilonewton equals to RR. You know, we have to write it in a professional way. We can say RR equals to 30 kilonewton. So I will write O here, but it's the same, but professionally we have to write it as RR equals to 30 kilonewton. This is kilonewton. So let's go to RL. How to find RL? So to find RL, we have to take moments around RR. Then we are taking moments around RR to find RL. So we are going to use the same formula, anti-clockwise moments, or anti-clockwise moments equals to clockwise moments. So then let me change the color here to, okay, let me try to change the color to black. Yeah, and then here let me remove the line. Okay, it will be like this. Let's start. Let's go to the beam. If you can check on the beam, we have to identify the anti-clockwise forces and clockwise forces. Remember, we're taking moments around this one, RR, to find RL. It means we have to identify the anti-clockwise forces and the clockwise force. So if you can check, 10 kilonewton is anti, this one 10 kilonewton is anti. If you can check here, I'm trying to check, this one is clock and that one is clock. Let me write clock here. Or even this one. So this one is anti RL, it's anti-clockwise. We're taking moments around RR. So it means we'll do it in this way. We group them. We write anti-clockwise forces under anti-clockwise moments, and then the clockwise moments we'll write under clockwise moments. So let's check. Let's start with the first one, which is 10 kilonewton multiplied by the distance, which is 1 meter, then plus another one, which is anti. It will be RL multiplied by the distance. Our distance is the distance between the supports, which is 1 plus 2 plus 1. Then it's 4 meters, equals to the clockwise moments. Okay, let's check the clockwise moments. We have 20 multiplied by the distance, multiplied by the distance. Our distance is 10 meters, plus 10 kilonewton multiplied by the distance. So yeah, I think we are done. Let's go through the next step. The next step, we are going to multiply everything, which means here it will be 10 kilonewton meter plus 4 RRM equals to 20 kilonewton meter plus 30 kilonewton meter. Yeah, like this. So we add, then we apply the subject with the formula, then so that we can left with RLM on the right hand side equals to, then we can simply add 20 kilonewton plus 30 so that we can get 50. Then we subtract 10 kilonewton from the right hand side. 4RLM equals to 40 kilonewton meter. Then at the end we are going to divide by 4 to get RL. So this is 10 kilonewton. This is the answer. Let me change the color to red and underline. Yes, like this, which means yeah, now we are using RR and okay, RL. So let me do something here. I want it to be red. Okay, yes, like this. Okay, let me leave it as like this. You see, this is how we calculate RL and RR, applying the law of moments. Applying the law of moments, this is our answer. Yes, let me erase here. I'm trying to clean up everything here. Yes, like this. Yeah, let me see. I will be writing a value here for RR and that one for RL. Okay, like this. So this is how we calculate reactions. Thank you for watching. Until we meet next time doing shear forces.